So good afternoon. In the morning session, we discussed about the next concepts which we have studied in the first chapter, that is simple stresses and strains. So we were on the concept called as temperature stresses, as you can see on the screen, temperature stresses. So what are temperature stresses we discussed, then how to calculate the temperature stresses, we have understood that. What do you mean by free expansion, what is expansion prevented, and how the stresses are proportional to expansion prevented, that we discussed last this one in the last meeting. Now let's go to the some more questions like this question which we solved in the last session before we end up the morning session. That was this particular in this question we were having copper and steel rod subjected to some change in this one, subjected to change in temperature, and because of the combination of material, how the material behaved. Okay, the copper was as copper having alpha, that is coefficient of expansion more, it tried to expand more. Just a minute. Yeah, this was the question which we solved morning session. So copper and steel, copper having greater alpha, that is coefficient of linear expansion, it tried to expand more, but because of steel being in the same place and rigidly connected to the other end, so steel oppose it. Okay, and vice versa, means copper tried to drag the steel and steel tried to drag copper in the backward direction. So that is why we have written these two equations. Okay, the free expansion minus expansion prevented for copper, and free expansion plus expansion added for this one, steel. Now similar lines, on the similar lines we will solve another question where the materials are not in parallel case, they are in series case. For example, this is the question which you can see. So there is again a composite bar consisting of steel and aluminium as shown in figure. There is a composite bar of steel and aluminium as shown in figure. Now they are connected in series with each other. Okay, the figure is at 60 degree. Right now the temperature is 60 degree. Find the stresses in two rods when the temperature falls to 20 degree. Now there is no rise in temperature, there is fall in temperature. Okay, there is fall in temperature. So the temperature falls to 20 degree after some time, and then because of that the steel and aluminium should go for contraction, but that contraction is not even allowed because we have rigidly connected ends. Both the ends are rigidly connected, so the compression is not allowed. The compression is not allowed. So if the compression is not allowed and the material is that means there will be some elongation.
अगर तेरा नाम होता मोटू.
Who is this? ये रोल नंबर 37 असलान खान कौन है? Okay, kindly unmute, mute yourself unless and until you want to talk. Okay, okay, fine. So what we are, compression होगा यहाँ पे, right? तो अभी E for steel and aluminium are given and the alpha for steel and aluminium are also given, and you have to find out okay, what are the stresses in the rods. Okay, so now can you tell me, anybody from you? Now I would like to hear something from you. Okay, so just tell me, you can go ahead, unmute yourself and tell me how to start with this. What things you can write? The very first thing, we will write down the data first which is given. So let's write down the data, steel and aluminium. Okay, now in steel we have the area for the area of cross section of steel. It is 250 mm square, and the area of cross section of aluminium, it is 375 mm square, right?
Yes.
The length for aluminium is given. The length for aluminium is 400 mm, and the length for this one steel is 800 mm. So that is given in the problem, and rest alpha and everything is given. So this is alpha given, this is E given. Okay, what? Now what is the delta T here? What is delta T?
40 degrees.
Whether we should write it positive or negative?
Sir, negative. Falls
Let
to
me write
20 degrees Celsius.
negative 40 degrees Celsius. Negative change is there. Okay. So negative 40 degrees Celsius is the change. Now we have temperature change also. Okay. Now how to start with this? As we have studied this earlier example also, similar lines पे हमें ये solve करना है. Only the thing is here temperature is negative, means temperature is decreasing instead of increasing. Okay, now what will happen? So there will be free, instead of writing expansion, we will write compression. Nothing else, right? So there will be some free compression of steel and free compression of aluminium, but which is not allowed. Now here, who is going to compress more, aluminium or steel?
Aluminium.
Okay, so as you can see, the aluminium is going to compress more because your alpha for aluminium is high as compared to this one. So you can see ये aluminium compress होगा, ठीक है? When this aluminium will try to compress more, it will try to pull the steel. ये steel को वो oppose करेगा, right? Steel also tries to compress. Aluminium को compress होना है, but aluminium steel को oppose करेगा and steel aluminium को oppose करेगा. Are you understanding it? Earlier case में the copper was supporting steel and steel was opposing copper. इसलिए हमने जो earlier example solve किया, इसमें हमने ये जब equations लिखा था free expansion minus, तो यहाँ पे एक जगह पे minus आया, ठीक है? You can see this is minus but this is plus. But this is not the case in our right now this particular case, because here one material was supporting and other was opposing. The copper was supporting and the steel was opposing. But here in this particular example, both the materials are going to oppose each other. Aluminum wants to contract and steel will try to oppose, and steel wants to contract, then aluminium tries to oppose, and as a result the net deflection is how much? How much is the delta L? Net delta L for this particular case, the net delta L is 0 because they are in the rigid supports. They are in the rigid support, so the net delta L is 0. That means whatever is the elongation of total elongation of aluminium plus total elongation of steel will give me 0 as the answer. Okay, so I will write down that here. Now you can see how I write down. So here aluminium पे जो force आएगा, अगर aluminium इधर push करता है तो steel उसको यहाँ पे push करेगा. So equal and opposite forces आएंगे. Force due to aluminium and force due to steel is going to be remaining same. That is one case which we know. So let us write down that first case. We will write down load equation. कोई भी equation पहले लिख सकते हैं. So I am writing the load equation first. The load in steel will be same as load in aluminium, but the load is nothing but stress AS into sigma S, and this is sigma AL into area for aluminium. Now these two things I know. Sigma S is unknown, but area for steel is known to us. Area for steel is 250 mm square, and the area for aluminium is 375. Right? So I can get one relation between sigma S and this one. So sigma S is equal to 375 divided by 250 into sigma aluminium. So can you tell me the fraction here? Yes, can you tell me the fraction?
Sir, 1.5.
Yes, fraction is 1.5. Okay, so let's say 1.5 I'm writing. So 1.5 is the fraction. Now I got this equation 1. How to go about second equation? How will you write down the deflection of aluminium? Let's say for aluminium I'm writing. For aluminium, okay, what is the net deflection? Deflection for aluminium. It is free contraction. Instead of expansion, I am writing contraction now. Free contraction minus the extension due to steel. Have you understood this? Why I am writing extension? Aluminium earlier wants to contract, but steel उसको extend कर रहा है because steel उतना contract नहीं हो पा रहा. Okay, so therefore I need to write down this one. And free contraction, sorry, free contraction minus this one. So now I'll write down the formula. The free contraction. Free contraction is basically alpha aluminum, length for aluminum, and delta T. Okay. Now you have already taken contraction, so no need to sign the take this sign. We'll take this as positive sign only, delta T. Already हमने contraction की बात कर दी है, so no need to again go to negative sign. Okay. Now let's go for the extension value. Extension due to steel. What is the extension due to steel? It is the sigma for aluminium. Okay, the force exerted by the steel. So it is sigma for aluminium, then L for aluminium upon E for aluminium. Okay, now this is my delta L for aluminium. Let's say this is equation 2. Similarly for steel, as I explained you, here both the elongations, both the materials are going to oppose each other. So दोनों केस में negative आने वाला है. So delta L for steel is equal to, again I will write down, that is free contraction minus extension due to aluminum. Okay, so free contraction is alpha steel, length for steel, delta D same है दोनों के लिए, minus sigma for steel, L length for steel upon E for steel. That is equal to my delta L for steel. Let's say this is equation 3. Okay, this is equation 3 which we got. Okay, now let's go to the next one then. Now we need to solve. अभी solve करने के लिए क्या करना पड़ेगा, हमें इतना तो पता है कि जो भी changes आया है, finally the total length of the steel and the aluminum is not going to change. That means whatever the delta L I have calculated for aluminum, positive, negative, I don't know, and the delta L for this steel, summation will be equal to 0. मतलब हमें पता नहीं है कितना क्या बढ़ने वाला है क्या कम होने वाला है, बट दोनों का अगर स्टील बढ़ता है तो एल्यूमिनियम कम होगा, एल्यूमिनियम बढ़ता है स्टील कम होगा, बट द नेट इफेक्ट इज 0 because the rigid supports are not going to move, and if the rigid supports are not going to move, that means that is be 0. Yeah, then what next? Here both are opposing each other, so we will substitute this and try to calculate. So let us substitute now. Alpha AL is known to me, it is 23 into 10 raised to minus 6 into the length of aluminum is known to me, it is 400 mm, into delta T I will take at 40, minus alpha aluminum is unknown, into length for aluminum is 400 and E for aluminum is, we will convert it to MPa. Aluminum E क्या कितना है, 70 GPa दिया है, तो 70 into 10 raised to 3. We have converted this into MPa. Okay, ये हो गया पहला टर्म. उसमें हमें second delta L for this also we need to add. So I will write plus alpha S. Alpha S is how much? 12 into 10 raised to minus 6 into the length for the steel is 800 into the temperature is again 40 minus sigma for steel, length for steel is 800 upon this is 200, so 200 into 10 raised to 3 is equal to 0. So when you simplify this, you are going to get some equation in sigma L and sigma S. Okay, and that is equal to something. So that is you are going to get the fourth equation in terms of sigma, the stress in steel and stress in aluminum, and you have one more equation, the equation 1. So by using these two equations, you will be able to calculate sigma steel is how much and sigma aluminum is how much. Once you know sigma steel and sigma aluminum, you will be also able to calculate delta L for aluminum, and you will also able to calculate delta L for steel. Okay, so I'll wait for 2-3 minutes here. All of you are requested to scribble it down and try to solve and get me the answer. At the same time, I want the answer for the last question also. I need to update it in this particular PPT. Yes, before this, let's start solving this particular question. Then I want answer for the previous one as well. Yes. So how many are there in the group? 88 people are there. Now let's see how many can solve. All of you. I'll name out one or two to answer. so that it will be Imtiaz, if you are not listening to this, at least don't disturb. Okay. Okay, I'm waiting for 2 minutes. Give me the answers quickly. Yes, make a roll number 9 is there. Tejas, can you unmute yourself? Yes.
sir.
Solve kiya? You get the answer? Okay. Give me the answer. Tejas will give me one answer and we will verify Tejas' answer with, I'll name out, with make a 19, Bhagyashri. Or these two answers, they will give the answers. Okay, quickly. By that time, somebody gets the answer, put in the chat box privately to me. Don't share your answer. Quickly. Okay, done. 1 minute is over. At least कुछ आधा आंसर तो आया रहेगा sigma x and al. Yes. Tejas and Bhagyashri. Yes, I'm getting some answer from the chat box. Okay. Siddhant Shinde has answered. Yes, yes. I'm showing it. Wait a minute. Yes, sir. Siddhant has answered something. Let's verify with others. Siddhant, calculate the other two things, that is delta L for aluminium and steel.
Okay, sir.
Love Shah also answered, but Siddhant and Love, both your answers are not matching. Now I'm again confused who is correct. So just to quickly recheck your answers. There's no similarity. Okay, Arslan Khan is also has answered, and he is nearer to Love. So now we have two people giving same answer. So Siddesh, again you need to check the answers there. Even Suditi is giving the same answers. Sania Bhurke also giving the same answer. And what about Tejas and Bhagyashri? They have not answered. The question is meant for them. Yes, what about? Roll number 9, 19, किधर गए?
Sir, I'm there in lecture, but I don't have my calculator with me.
Why? Where is your calculator?
Actually, I live in hostel.
Okay.
So it is there in Mumbai, and I am at my hometown.
Mobile तो होगा ना, even mobile has scientific calculator. Okay,
Okay, sir.
but next time download it scientific calculator in your mobile and try to calculate. Okay, what about Tejas? Prajwal, just one answer is correct, but the other is not as per the other. So Prajwal, you have to check the other answer. That is for steel. Arsh Goro also gave answer. Tejas is saying 2 minutes. Okay, fine. Okay, fine. Another 2 minutes we can wait. Tejas, you have to be very quick for the next time. I'll reserve your chance and you'll be answering for the next question as well. Okay, good. So let's continue. As per the public calculations from various people from mechanical A, B, both, I'm getting the steel answer as 96 point something, right? Is it correct?
Yes, sir.
96.3. Okay, if not,
Yes, sir. 96.315.
yeah. So I'm getting the sigma S answer as 96.3 MPa, and whereas aluminium as how much?
64.2.
64.2 MPa. Very good. So these are the most repeated answers so I'm getting in the chat box. So assuming these are true, we'll keep these. Now what about delta L for aluminium and delta L for steel? Sanya Burke has answered delta L as 64.4 and delta steel is 96. Is it true? Because these values are matching this sigma values. So I'm a little bit confused.
No, sir.
Yeah, that is why. Just give me the answers for okay, fine. Okay, some Sudhiti is giving the answer as 1.2 for aluminium. She got 1.2 into 10 raised to minus 3, right, in millimeter. And for steel, is it correct? And you will get one positive and the other should be negative, I guess. Yes, aluminium, somebody else has got minus. हाँ, but ये आंसर बहुत ही ज़्यादा बड़ा आ रहा है. लव योर आंसर इज अगर वो मिलीमीटर में है तो भी ये बहुत ज़्यादा मिलीमीटर हो गया. उतना तो लेंथ ही नहीं है अपना. कैन यू करेक्ट दिस आंसर quickly? इतना टाइम क्यों लग रहा है? बट आई डोंट गेट. ऑल ऑफ यू आर हैविंग द साइंटिफिक कैलकुलेटर, राइट? आई एम जस्ट आस्किंग यू टू कैलकुलेट, नथिंग एल्स. Okay, so aluminium and steel. Now Aslan Khan is saying some different answers, so let me go with him unless and until somebody corrects us. So it is, he is saying 1.17 for aluminium. He is 1.17 10 raised to minus 3, and for steel he is saying 1 minus 1.16 into 10 raised to minus 3. Is it so? ऐसा आंसर आ रहा है क्या? Okay, they are seem to be correct because
yes sir, इसी रेंज में आ रहे हैं आंसर्स.
जितना पॉजिटिव उतना नेगेटिव आना चाहिए to have the 0 as my total. So this seems to be correct. So very good, Aslan, you have correctly answered. Thank you. Okay, so let's continue now. But be quick, answer फटाफट दिया करो so that we'll not waste some time. Okay, good, you are trying, very good. Now let's continue. So have you understood this particular question? Here when we have in series kind of thing, तो यहाँ पे दोनों में नेगेटिव साइन आया. ओके, पैरेलल होता है तो वी आर लिटिल क्यूरियस कि कौन सा पॉजिटिव है कौन सा नेगेटिव है, because in that time some one materially must be supporting the other and other must be opposing, but in this case both are going to oppose each other because it is fixed at both the ends. Okay, now let's go to the next question. On the similar line we have this particular question. Okay, so now how to start this particular, why I'm getting this, how to start this particular question. So अभी ये particular question में देखो, now nothing, diagram is not given, you have to identify what is the case and then you have to solve. That a steel tube is there, 50 mm internal external dia and 3 mm thick. There is a steel tube 50 mm. So let me draw the diagram for our reference. So let's say this is a steel tube जिसका external and internal diameters are given. So I'm drawing the steel tube. Imagine this is a tube. Okay, now this is a tube. The external diameter is known to me, it is 50. Okay, the external dia is 550 and the thickness is how much? 3 mm. Okay, now it is rigidly connected at the ends, but it has a solid copper bar. मतलब इसके अंदर एक copper bar भी है. We have a copper bar at the center. This is of copper and this is of steel. ठीक है, अगर इसका साइड व्यू मैंने ड्रॉ किया, साइड व्यू में वो ऐसा होगा. दिस इज माय ट्यूब, इसके अंदर ये मेरा स्टील ट्यूब है. एंड उसके अंदर मेरा एक रॉड है. गेटिंग इट? दिस इज कॉपर and this one is steel. What this? And they are fixed at the both ends. दोनों end पे fixed है. This similar kind of the question, first question which we solved. Okay. The earlier, what is the delta T here? The delta T is the final temperature 170 minus the initial temperature 20, which is 150 degrees Celsius. That is my delta T. Okay. Now what is the area for steel? That I'll have to calculate because it's a hollow tube. So it is pi by 4. Now they have given the inner diameter, outer diameter से भी calculate कर सकते हैं. So pi by 4. The outer diameter is 50 square. So I'll be writing outer diameter as 50 square minus the inner diameter is 3 अगर minus कर दिया तो 44 आएगा. 44 square. So this will give me some answer in millimeter square. Tell me the answer, how much? And what is the area for copper? It is pi by 4 into the diameter of 35. So pi by 4 into 35 square. Tell me the answer in millimeter square. Quickly. Yes. Chat box में दिया क्या? Okay. Now Tejas is saying 564 watt for ये किसका आंसर है?
Sir, can you explain this once again?
Which part?
That copper part. I got disconnected for some moment and
Okay.
missed that.
As you can see, read the question. The steel tube is there. So I have drawn, this is a steel tube जिसका external diameter 50 है और एक hollow है. उसके अंदर एक solid rod है. दिख रहा है यहाँ पे, ये steel tube है बाहर, उसके अंदर solid rod है. दोनों को fixed end पे fix किया है. दोनों. अभी जो अगर मैं इसको temperature heat करूँगा तो copper and steel both are going to extend equally. मतलब going to extend equally. But what is that extension? I don't know. But वो दोनों equally extend करेंगे. That I know. ये उतना तो हमें पता है. तो अभी इसके लिए मैंने क्या क्या हमें गिवन है, उसके लिए the things which are given to us we are writing. Yes, Tejas, very good. अच्छा, sorry बोल रहे. Okay, is this correct now? 442.96 is for steel.
Yes, sir.
Yes, sir.
Yes, sir.
446. 446.
442.
442.96
442.96
and 962.11.
ये उल्टा नहीं बोला तुमने? कॉपर का ज्यादा है कि steel का?
नहीं सर, ऐसे ही है. ऐसे ही है, कॉपर का ज्यादा आ रहा है.
हाँ, एरिया क्रॉस सेक्शन है ना, बराबर. हॉलो है ना वो, आएगा. बराबर है, ठीक है, चलेगा. चलेगा. People are answering. Okay, 961 from 0.65. तो
No, sir, 962.11.
962.11 ठीक है. तो नाउ करेक्ट राइट. तो अभी मुझे कॉपर और स्टील का एरिया पता है. हाँ, अभी क्या करेंगे. नाउ आई वांट इनपुट फ्रॉम योर साइड. अभी मैं कुछ लिखने वाला नहीं हूँ. बताओ तुम क्या लिखो. चलो एरिया भी मुझे पता है. अल्फा कौन ज्यादा एक्सटेंड करेगा. Now you can see, is this a parallel case or a series case? This is a parallel वाला case, right?
Yes, sir.
Parallel case में क्या होता है. One material supports and the other opposes. बराबर. तो कौन सपोर्ट करेगा इसमें भी. As you can see, copper has got higher alpha, तो copper सपोर्ट करेगा and steel is going to oppose. But दोनों का जो भी elongation आएगा, जो फाइनल elongation है डेल्टा एल, वो स्टील के लिए और वही सेम कॉपर के लिए वो सेम रहेगा जैसे हमने उधर पहले वाले क्वेश्चन में दिया था वैल्यू. हाँ, बट अभी जो फाइनल इलोंगेशन है स्टील का, अगर मैं स्टील के लिए लिखता हूँ तो स्टील में क्या होगा. स्टील में जो फ्री इलोंगेशन होगा उससे और कुछ ज्यादा होगा बिकॉज कॉपर उसे और ड्रैग करके आगे लेके जाएगा. तो आई कैन राइट डाउन दिस एज फ्री इलोंगेशन. फ्री इलोंगेशन का फॉर्मूला लिखता हूँ मैं डायरेक्टली अभी. तो फ्री इलोंगेशन का फॉर्मूला है अल्फा फॉर स्टील, लेंथ फॉर स्टील. लेंथ तो दोनों का सेम है तो नो नीड टू राइट डाउन द लेंथ. दोनों का लेंथ पता है मुझे बट अभी एल लिखा मैंने डेल्टा टी. ठीक है. माइनस सॉरी माइनस नहीं, स्टील के लिए प्लस होगा बिकॉज स्टील और ज्यादा इलोंगेट होने वाला है राइट. आई होप आई एम मतलब वॉट एवर आई एम सेइंग यू आर अंडरस्टैंडिंग इट. दोज हु अंडरस्टूड दिस पर्टिकुलर क्वेश्चन. तो यही बेसिस पे मैं लिख रहा हूँ. यहाँ पे मैंने सिंपली अलग अलग करके लिखा था. जैसे मैंने देखो यहाँ पे भी कॉपर के लिए माइनस आएगा, स्टील के लिए प्लस आएगा बिकॉज स्टील ज्यादा इलोंगेट नहीं करता, उसका अल्फा कम है. तो स्टील को और कॉपर और ड्रैग करेगा आगे, इसलिए मैं यहाँ पे प्लस लिख रहा हूँ. एंड वो जो ड्रैग करेगा वो अमाउंट कितना है, दैट इज पीएल बाय डेल्टा ए, पीएल बाय ई. बट पी बाय ए को हम सिग्मा लिखते हैं तो इसलिए सिग्मा एस, लेंथ सेम है दोनों के लिए, अपॉन ई फॉर स्टील. ओके. एंड दैट हैज टू बी इक्वेटेड विद द अनदर डेल्टा एल. नाउ दिस अनदर डेल्टा एल इज basically alpha for copper, length for copper into delta t minus something. Here there will be minus होगा sigma for copper, length upon e for copper. Got this? Are you understanding it?
Yes, sir.
Yes, sir.
Fine. So now
Yes, sir.
अभी क्या करेंगे, इसको सिंप्लीफाई
cancel हो जाएगा
करेंगे. जो वैल्यूज मुझे पता है वो सब्स्टिट्यूट करो. अल्फा फॉर स्टील इट इज 12 into 10 raised to minus 6. अल्फा फॉर कॉपर सॉरी इनटू लेंथ फॉर स्टील इज, लेंथ इज गिवन टू अस 350. तो दोनों ऐसा, वैसे भी लेंथ लिखने की यहाँ पे जरूरत नहीं है. यू कैन सी लेंथ में गए सब जगह से लेंथ में कैंसिल कर सकता हूँ ना. यहाँ से दिस एंड दिस आई कैन कैंसिल आउट द लेंथ. सो नो नीड टू राइट डाउन. डायरेक्टली विल राइट डाउन डेल्टा टी वैल्यू. डेल्टा टी इज हाउ मच, 150 plus sigma s is unknown. Es, how much is the steel, that is 200 into 10 raised to minus 3 is equal to alpha for copper is how much. Alpha for copper is 18 into 10 raised to minus 6 into 150 minus sigma for copper upon 100 into 10 raised to 3. ठीक है. इसको सिंप्लीफाई करना पड़ेगा तुम्हें. then you will get equation 1 which is a relation between sigma s and sigma s.
सर 200 into 10 raised to 3 आएगा ना.
हाँ, ये +3 आएगा.
Yes, sir.
Okay. Okay. So now next क्या है इक्वेशन 1 तुम अभी कैलकुलेट करोगे. आई एम नॉट राइटिंग दैट इक्वेशन. यू हैव टू कैलकुलेट इक्वेशन. एंड आफ्टर दैट व्हाट इज द सेकंड रिलेशन व्हाट वी यूज. दिस इज द फर्स्ट रिलेशन जो हमने यूज किया डेल्टा एल को इक्वेट करके. द सेकंड रिलेशन इज लोड. आई नो दैट द कॉपर एंड स्टील बोथ आर गोइंग टू गिव द सेम लोड ऑन ईच अदर. तो कॉपर हो जाएगा सिग्मा सी into area for copper and this will be sigma s into area for steel. But I know the sigma c into area for steel is and area for copper are known to us. It is 962.11 and is equal to sigma s into 442.96. Okay. So when you write down sigma c is equal to 442.96 divided by 962.11 into sigma s. So on this you will get that second equation, and on solving 1 and 2 you will get the formula for sigma C, the answer for sigma C and sigma S. Once you know both of them, you have to also find the increase in the length. So increase in length मतलब total delta L कितना आया? So either you solve for this one or this one. मतलब तुम कोई भी एक side का solve करो. The total delta L is nothing but alpha C into L into delta T. अगर मैं copper का use करता हूँ तो plus, sorry copper के लिए minus है, minus sigma C into L upon EC. So substitute all your values of sigma C and here and get the answer in mm. Okay. So again, I'm going to wait for 2-3 more minutes. Now let me, Tejas is the one candidate who will solve this, and let me nominate the other one or two. Now from mechanical B, I guess. The mechanical B के लोग दिख रहे कि नहीं? Yes, Rohit Pal is here. Roll number 2. Can you calculate for us?
Yes, sir.
Rohit will calculate for mechanical B and Prithvi Shah, roll number 25. Okay, Prithvi, Rohit and Tejas. These three are going to calculate. At least दोनों का तो आंसर मैच होना चाहिए, so that we will confirm. तीन में से ये दो लोग का जो मैच होगा वो आंसर करेक्ट है. ठीक है, चलो क्विकली. And other people also can answer in the chat box privately to me. I'm having a look on this chat box. Tejas has calculated right. Very good. Now let's see. What about the second answer? Now I have one sample of answers. Need a verification from somebody else. What about other 89 people? 89 नहीं, 88 मेरे को छोड़ के. What about other 88 people? Sorry, 88 भी नहीं, Tejas ने भी आंसर दिया है. 87 people. Can you give me the answer? Yes, Love has answered, but again the same problem. Love and Tejas, your answers are not matching with each other. I am not sure who is correct or not. Now we'll need one more sample of answer. Check, both of you check it again, Tejas as well as Love. You have to be very quick in calculating because even in your competitive exams like GATE and aptitude exams, the SOM is a basic subject, core engineering subject, where you have to calculate. There you don't have a calculator also. Arslan Khan has come up with some answer. His answers are matching with Shashi and so I have two people, Shashi and Arslan. Their answers are matching with Love as well. So Tejas, you need to check your answers. I have three set of answers, those who are matching. So let's go with those. So as per these three people, Shashi Khatri, Arslan and Love, we have sigma C, sigma for copper as 43.144 MPa, and for steel it is 93.71 MPa. Okay, and give me the delta L value, or any one of you. Yes. In that delta L, we need to substitute the value of L as well. Yes. 0.7941. Is it so?
Yes, 0.794.
Very good. 0.7941. Yeah. Okay, Tejas also got the answer. Very, very good. Fine. 0.7941 mm is the total elongation in the tube after this much. So very good. We have successfully completed this. So we have solved 2-3 numericals on this particular case. How to solve the thermal stress problems, right? So all of you are very much well versed. You have to solve some practice problems also. So I'll be sharing and the assignment problems where you to solve this. Okay, but once again I'm telling, don't copy any questions from the assignment part. Okay, because